Okay, students, this is just going to be a short video where I calculate an answer to the question that I posed in an earlier video. So here's a graph of the motion of an object, and here's the question. The object initially moves in the positive direction away from its starting point. At t equals 8 seconds, the object changes direction and moves back toward the starting point. When does it reach the initial position again? Well, perhaps you remember that we found that the displacement, the positive displacement, delta x, from t equals 0 to t equals 8 seconds was the area under the curve, and that worked out to be 40 meters in the positive direction. So we need to figure out when the object has moved negative 40 meters. In other words, to the left 40 meters. We could do that by counting the blocks under the curve like we did over here on the positive area if we had the graph complete 2 additional times. But we don't have that. We could extend the graph and extend the axes, but that's a little cumbersome. So why don't we just calculate the value using the numbers that we can deduce from the graph? So I'll work on that. First thing I think I'll try is to figure out the acceleration of the object when it changes direction, or pardon me, doesn't change direction, when the acceleration changes direction from positive acceleration here to negative acceleration here. So I can use maybe this value and this value to determine the average acceleration. Remember, that is just delta V over delta T. And then I'll just plug in some numbers. So that would be final velocity, which is 0 at 8 seconds. So that'd be 0 minus 10 meters a second over the time interval would be 8 seconds minus 4 seconds. So that works out to be negative 10 meters a second over 4 seconds, or negative 2.5 meters a second squared. So that will be the acceleration as long as this motion continues with the same acceleration. So now I want to figure out when the object will have reached negative 40 meters. Well, I'll apply this equation, delta x equals initial velocity times time plus 1/2 acceleration times time squared. The initial velocity, since we're interested in this part where the object turns around and goes in the negative direction to some unspecified time down here, well, the initial velocity is 0 because at 8 seconds, initial velocity is 0. So that term will not matter. And we know what the acceleration is. It is negative 2.5 meters a second squared. And we also know that we're interested in when the object has traveled negative 40 meters to the left. So I can just plug in numbers and solve for t. First, I'll rearrange the equation. I just said that the initial velocity term, that drops out. So the basic equation is just this. Displacement equals 1/2 acceleration times time squared. I can multiply both sides by 2. 2 times delta x will equal acceleration times time squared. And then I could divide both sides by acceleration, and I'll get t squared, I'll move it to the left side, is equal to 2 delta x over acceleration. You should practice doing that yourself if you didn't follow that quick rearrangement of the equation. So that means that t squared equals 2 times negative 40 meters over the acceleration, which is negative 2.5 meters a second squared. So t squared equals, I already calculated this, negative 80 meters over negative 2.5 meters a second squared, and that gave me 32 seconds squared. So then I take the square root of everything, and t equals 5.66 seconds approximately. Okay, thanks for watching. Remember, what one fool can understand, another can.